we have another first-time speaker coming to the stage. So not yet,
Good luck.
but when I say his name, I want you to make him feel like a rock star, because it is terrifying to be up here, especially for the first time. So, up next, we've got Barrett Breshears. He's a mobile developer, has been for about a decade now, and he's gonna bring a hot take, which is we don't need backends. Which, as a backend developer, I'm ready to be convinced, but I don't know. We'll see. Okay. He is a very kind and gentle presence. I met him finally in person after being internet friends with him. I met him finally in person yesterday, and he just puts you at ease. So, let's make sure that he feels like a rock star. I'm about to say it. Please welcome to the stage, Barrett. Go get him.
Yes, there we go. Hey everyone, great to be here. I'd like to say thanks to the HTMX team for putting this on. It's really fun. It's my second year. Made some really good lifelong friends already last year that we've been good friends, so love this event and super excited and happy to speak at it today. So backends, where we're going, we don't need backends. That's my talk today. And it's kind of funny, Warren buffering had a profound, deploying apps is a solo standalone piece of software that kind of relates to this talk. And so you can just kind of see the genius there in that. And then also, it was pretty funny too that Ken got everyone that hates LLMs to raise their hand. So if you guys could just please leave, that'd be great. But no, just kidding. You probably haven't met the right LLM yet. So hopefully we can change your mind about that. So today's talk is about running LLMs on mobile devices specifically. So just a little bit about me. I've been doing mobile development for a really long time, since 2009. I love kind of everything DIY, HVAC enthusiast lately, because my AC went out, and do farming with my wife on our flower farm, so it's been really fun too. Love everything AI. I'm one of those guys that really enjoys AI wrappers, so that kind of lets you know where I'm at. And then just building local first too is really fun. And then a fun fact about me that's kind of AI related is I was in the 2001 Steven Spielberg AI artificial intelligence movie at 42 minutes and 43 seconds. So just gonna play that for you real quick. So I'll show you guys right where I'm at. Right there. So. Yeah, if this programming thing doesn't work out, if AI takes our job, I can hopefully get it back into acting. So why would we want to run LLMs on mobile? So number one, they have offline capabilities. That's really cool. No network required, and you get to just have that app working under really strange conditions and no network and that kind of stuff. Second is privacy. I know I don't really like the big AI companies having all the data, and I think Sam Altman just the other day said something about, most people use it as their therapist, but if they get a court order, they're gonna dump their data over to the authorities and stuff. And then also, if it's not your weights and models, then it's not your AI waifu. So that's important too, especially with the new Grok stuff, which is super weird. And then also it's instant, right? No network latency. It's cheap as well. So anytime like OpenAI comes out with like cool features and it's like, oh, they just killed your AI wrapper. If your wrapper doesn't cost anything to run, it's really hard to kill, in my opinion. And so that gives you a really huge benefit over the big AI companies. And then next, it's just flexible. You can do really cool things. You can select really cool, weird models on Hugging Face that are really unique and do cool things. You can also fine tune them, optimize them for specific tasks, and really cool stuff like that. So I did this demo for my family the other day, And I had the demo at the end, but I kind of wanted to run along so you guys could kind of see it a little bit better and have more time to kind of enjoy it. So we're going to kind of start with a demo. So the idea I had for my project was every year Carson goes offline for Lent. And so he's like my favorite Twitter account. So I thought maybe we could train a model to do some HTMX unhinged posting for us while we kind of walk through how we did this. So I grabbed a bunch of his tweets, I trained a model on it, and then we're going to kind of run it and show you how I did that. So the model that I'm using today is Tiny Llama, and then we're going to use the LoRa adapter for the training, and then the runtime environment, I'm using Llama C++. There's a really cool Swift library that wraps it for us, so we don't have to do any work on that. So if you're looking to run Llama C++, it's a pretty cool one. You have to check it out. It's called LLM Farm. And then we're running on iOS and Swift. So I have three. First off, let's just kind of take a look at the data that we used. So it's not the best. I didn't have too much time to work on it. But so these are some of Carson's tweets. They're really, I think, probably super bad training data. I'm not like a machine learning specialist or anything like that. So it's hard to tell if it's good or not. So like these are all his tweets. There's 600 of them. It's a pretty small data set too. But yeah, so that's what we used for the training data. And then as far as the Python script, I have two different ones. There's two different ways to kind of approach the training. You can create a LoRa for it, or you can actually embed the training data in the model. And so what it does is these scripts that I wrote with Python allow you to kind of feed the LLM the prompt, and then it guesses what the output should be, and then you give it what the output was, or Carson's tweets. And so then, depending on how different it is, it adjusts weights and all sorts of stuff like that. I'm not 100% sure on how it works, but that's kind of like the gist of it. And then as far as the implementation goes on iOS, it's pretty similar if you guys ever used like OpenAI's API stuff. You pretty much load the model. So that's done right here. And then you load the LoRa data that we just used to train. And then once that's loaded, you kind of just set your system prompt. So our system prompt is your htmx.org Twitter account, passionate and slightly unhinged advocate for HTMX. Your goal is to generate tweets based on a provided topic. And then the tweet must be short, punchy. So anyway, you get the gist of it. And then all we do is just kind of set system prompts. We set different parameters and that kind of stuff as far as like randomness and temperatures and all sorts of stuff like that. And then we just call it. So it's pretty straightforward. So let's see, I got my phone hooked up. I already built the project. So turn that off, turn on airplane mode. So let me get this started. It's still showing Wi-Fi for some reason in the status bar, but it's off, so. And it'll start running. So that's gonna run. Some of them are really weird and kind of unhinged, so you can blame Carson for that. But yeah, some of them are good, some of them are bad. It's definitely the training data. It's only 600 kind of data points, so it's pretty limited. The really cool thing too about this in these smaller mobile models is that you can train on like your computer. You don't have to send it to like a GPU farm to train, which is really cool. So you can do really cool things. So that's gonna kind of be running while I finish up the rest of my talk. Hopefully it's not too confusing. I'm sorry, not confusing, distracting. So this is what we needed to build it. We needed our base model that we picked. We needed the training data. All right, so I guess that's good. It's making me not so nervous that everyone's laughing, so I appreciate it, guys. So it's working, I guess. That's good. So we needed the training data and then the tools to run it, so the runtime operations. So with mobile, with iOS, there's three really good solutions for runtime options. We have Swift MLX, which is what Apple's developing right now, that allows you to run models. And then we have Onyx Runtime, and then we have Llama C++. So Onyx Runtime's doing really cool stuff too. They're super platform agnostic, and you can run it anywhere pretty much. Swift MLX is only for iOS and macOS, it's native stuff, and then Llama C++ is cross-platform. They have really cool Android stuff too as well. But yeah. So the performance from this. So what are we getting as far as like numbers and stuff out of this? Pretty much we're averaging like 45 tokens per second out of this little phone, which is pretty decent. The model is really small and stuff, and accuracy isn't great. And anyway, you'll see some of these are hit or miss as far as like what's coming out of it. But again, I think that's due to training data and just the limited data set, and I'm not like a training expert and stuff like that. But anyway, it's still pretty impressive. With like ChatGPT's API, I think it's like 50 to 100 tokens per second is what I saw. So it's pretty comparable actually as far as like output. I'm sure it's nowhere as precise. So I kind of wanted to see or show kind of like what the big models are at and versus these tiny Llama mobile ones. And so ChatGPT has a ton of parameters. We're at 175 billion. The amount of RAM it takes to run that model is 350 gigabytes. Just a lot of memory and a lot of power, whereas the tiny Llama is running at 1.5 gigabytes. GPU requirements, mobile laptop, so it's pretty cool, pretty lightweight. So how do we shrink these models small enough to get running on device here? So there's three main kind of like strategies with this. There's quantization, pruning, and distillation. So quantization, we're reducing the accuracy of it by just the amount of data that is stored within that model. Pruning is removing the connections in the neural network. And then distillation is taking like a really big smart model and then grabbing only the really important data from it and kind of training the small model with that. So here's just a quick demo on quantization. So if we wanted to turn it into an 8-bit quant, we reduce the size of the weights and the data in the model by turning it into an 8-bit integer. So instead of holding a 32-bit float, you reduce it down to an 8-bit integer. And so, like for example, if the original size is 7 gigabytes and we do an 8-bit quant on it, you reduce the file size by 75%, and now you're only at 1.75 gigabytes. So it's pretty substantial on what you can do with quantization. But when you reduce these and you make the precision, I guess what they call it, smaller, the models are a lot less accurate and that kind of stuff. So there's trade-offs everywhere that you have to decide on what's important, and on mobile, getting it to run is like the most important thing. So the next method for kind of reducing the size is pruning. So removing the connections between the nodes. And so, yeah, this one's pretty straightforward. You just remove connections, and there's 4 main types of pruning. There's magnitude, structured, unstructured, and gradient-based. And I could go into those, but I don't know if it's too important. It takes, I think, special type of training equipment and stuff like that to do this, and it's like pretty complicated. So this isn't something that most people do as far as like just trying to get it to run on mobile. And then distillation. So like I said, this is where you take a teacher model and you train a much smaller model. And the example I gave is like learning from a master. Like if you're learning how to cook, you only need a couple recipes to make a meal instead of knowing all the specific data that like a master would know. So that's kind of the same principle of the distillation there. So there's a bunch of really cool mobile models that are available today. Tiny Llama, Phi 2, Mistral, 7B, Gemma 2B, and then the Llama 3B. So Tiny Llama is definitely the smallest right now. It's still really big, so the model that I used, I had to quantize it down to, I think, 4 bits to get it to run well on my phone. So the full-size model's at 1.5 gigabytes, and so it has to load that whole model into memory, and so you have to get it down. So when I did that 4-bit quantization, I got it down to 600 megabytes, so it could run on the iPhone there. So yeah, the Tiny Llama is like a good all-around fun model for doing stuff like this, and then Phi 2 is good for coding and reasoning stuff, and then Mistral and the Llama 3 they're a lot bigger, but they have really good amount of data and pretty precise and stuff. So once we do this and make them smaller, they are definitely less useful and helpful and accurate and all that kind of stuff because of the trade-offs. And so there's kind of challenges of how do we make it smart again and useful. So providing rich context. So Gemini has like 1 million token context now. It's crazy, it's huge. With this model, I believe it's 2,048 tokens is the max input size, so it's a lot smaller. So we can't keep feeding it context like the whole conversation like normally you do with like API LLMs. So what we have to do is like before we like send input to the AI stuff, we would query a local database first where you're getting any kind of context, adding that back in, just small snippets so that you could kind of have a full-featured LLM experience. The next thing that we can do is using on-device vector databases where we can load like documents and stuff. So for example, if we wanted a really helpful HTMX code helper or assistant or something like that, we could grab the documentation or whatever, put it into PDF, run it into the vector database, and then anytime the user would put their input in, and we could query that vector database, get any like helpful data that would be in that document, and then we could send that into the context as well. And then lastly, the fine-tuning stuff that I kind of showed here, where it kind of gets the tone or voice of what we're trying to achieve here, and that works really well as well. So, kind of wrapping up here, small models can be really powerful with the right techniques. On-device AI is private, fast, and cheap. And your phone's definitely not the back end yet, so Aaron, you don't have anything to worry about. But this stuff is getting really optimized, and hardware is getting a lot better. And I would imagine in the next few years that it's going to get really, really good. And then also Apple is investing heavily into this stuff. I know their AI stuff in implementation right now is terrible, but they have this new stuff coming out with iOS 26 called their foundation models. And anyway, to implement on-device AI, it's 2 lines of code now. You select the model, and then you set your prompt. So I would imagine like tons and tons of apps in iOS 26 that's coming out this year are going to have just a lot of cool AI features. So yeah, I think this is really cool technology, and it's really accessible for anyone. Like I said, you can train on device or on your computer, which is really cool. And yeah, so if you want to connect, I'm on Twitter, or send me an email. I'd love to talk to you about building stuff with this. So that's it.
All right. That was a heck of a first ever talk.
Thank you.
Nicely done.
Very nervous. Shaking
No, you did
shaking
great.
like a leaf up here, man.
Yeah. So talk to me about this quantization
Quantization.
and parameterization. So is that something where you have to take the full model and tune it yourselves?
Yeah, so on there's a bunch in Python, you can write these scripts that do this, and there's a bunch of open source libraries. And so you specify the model, the libraries go through each of the data points in that model, and they take it like from the 32-bit integer and down to it.
And are those like smaller models available? Like, let's say I wanted to put one of those smaller models in.
Yep.
Is that available anywhere, or am I doing that Python work myself?
No, they're available. Some people convert them and format them for you, and they'll put it on Hugging Face, but some of them aren't available. But it's super easy to just ask ChatGPT to help you write a script to convert pretty much anything.
And do you have a heuristic of like use cases that's good for on-device and use cases that you would keep behind an API? Is that something that you think about?
Yeah, just anything that requires a lot of context would be a good use case for API. But yeah, there's a lot of cool things too. Like with Onyx, you can run different types of models. So not just text generation, you can do image generation, you can do text-to-speech stuff that's like, almost a substitute for 11 Labs. It's very expensive. And so there's a lot of cool, interesting use cases for this.
Very impressive. Well done. Y'all give it up for Barrett.